Okay, so I'm going to open up the new a new blank file here with the architectural template, and we're going to get in and talk about structure. Now, more and more, we are seeing structural engineers who are using Revit for their design work. Revit has a good set of structural modeling tools, and one of the advantages for a structural engineer who is using Revit for design is that, of course, they have a 3D model not only for coordination purposes, but also because there are structural engineering analysis platforms out there that will accept a Revit model, and they will do various structural analyses of the Revit model, including seismic. So these are, it's a great tool for a structural engineer to be able to get that testing done. In times past, if an engineer wanted to do that, they'd have their working drawings in AutoCAD, and then they would build a separate 3D model in another platform. So now, much like architects can do their rendering and their working drawings in the same platform, and of course lots of other analyses as well that architects can do, energy analysis and so on, structural engineers can now do their analysis and their working drawings using the same data set. So that's a big deal. So if your structural engineer does not use Revit, it's probably still worth your while to model some aspects of the structure of the project. It's just worth doing. So what I'm going to do here, I'm just going to pull up a Revit model of a project done in not too long ago, where I modeled the structure for the project. So just opening up that file now. Okay, so this isn't a too terribly complicated project. It's an automotive dealership. So if we look at the exterior here, just a General Motors dealership. So you can see we've got the various brands here. So this was a renovation of an existing building. So this used phasing. So here, this is kind of the existing building. There was a showroom. We didn't model it in its entirety, but there was a kind of a round glazing wall at the front and some glulam beams, which were in the middle here. So when we went to do the renovation, we decided that we would preserve those glulam beams and extend the structure. So what ended up happening is that those glulam beams were retained, and we added some steel structure to capture the ends of those beams and retain them, retain the ends so that we could still have a clear span, more or less, within the showroom. Now, this also became very handy to have this information here when we were talking coordination purposes. So, just getting the chat window up here so I don't miss anything. There we go. So when it came down to mechanical design, now any of you who've been in the design industry for a while know that when it comes to coordination problems between consultants, especially conflicts in terms of space usage, especially with regards to services, it's always structural and mechanical who are creating problems on site. And that's just because both of those disciplines are responsible for parts of the building that take up a lot of space. So structure takes up a lot of space and ductwork takes up a lot of space. And as a result, we run into situations where those two disciplines' work will come in conflict. So as an example here, we've got these glulam beams, and you can see them here. And so not the structural engineer, but the mechanical engineer wanted to put in a big 24-inch deep duct right in between these two glulams, running down to the front of the building So here, let me get the later phase up here. And so what they want to do was they wanted to get that ductwork here in behind the front curtain wall, right up in behind these columns here, so we can kind of peek inside there, and you can see there's that whole bulkhead space. So you wanted to get that duct to come down in between those beams and into this zone here for air delivery into the showroom. So I saw the plans and I was like, I don't know if we have 24 inches of space in the ceiling to facilitate that. So here's our showroom plan. So I went and cut a little section right through the front here. And so we had modeled the structure for the project. Now, this isn't a section that went onto a sheet. We just used this section to help us with coordination needs. So here's the beam that the structural engineer said was going to be needed to support those glue lamps. Here, up above, that's the old 2x8 sleepers, not 2x8 sleepers, purlins, that were put on top of the glue lamp beams to support the old roof. So on top of these old glue lamps, there were 2x8 joists that ran in between them, and that's what we're seeing here. Now, we added some 2x12s onto the end of those, and then those were in turn carried by the exterior wall. So 24-inch deep duct. How much room do we really have? Certainly not 24 inches, about 16 inches. So by the time you get that little connection flange around the outside edges of the duct, it couldn't be 24-inch duct anymore. It actually ended up having to be a 10-inch duct because he needed to get some clearance underneath our new roof joists here in this zone. So having that 3D model with the structure in it was super helpful for us for coordination purposes. So down here we had the steel columns and open web steel joists that the structural engineer had specified for this new drive-through service area. And that all this new structure here took me, I don't know, maybe a day or two with interruptions to put into the building. And boy, did it ever come back to help us at various stages in the project. So even if your engineer isn't using Revit, it's highly recommended that that you folks, somebody's got to model the structure. For coordination purposes, it's just so important. Now, we are going to look at some of the basic tools for structural modeling. The different kinds of tools that we're going to be looking at tonight on the structure tab are columns, beams, and foundations. So we're going to be looking at the pad footing, which is the isolated footing, and the strip footing or the wall footing, which is this one right here. So we're going to head down that road here in a few moments. Now, structural engineers who use Revit, you need to keep in mind that a structural engineer's drawing is a different animal than an architect's drawing. So when you look at a structural engineering floor plan, that floor plan shows you the structure that is supporting that floor. So if you look at the level 1 structural plan, it shows you the structure that is underneath level 1 holding it up. Whereas, of course, if you go to an architect's floor plan, their level 1 floor plan shows you what is above the floor, not below it. So there is a difference, and that comes down to view range. So if you were to look at a structural engineer's view range, it would be set up differently than the architect's view range. And if you use the structural engineering template in Revit, you would find that your views would look quite different than they would if you start off with the architectural template. When you place a structural object like a column into your view, now here I'm in the architectural template, but I'm using a structural column. What Revit tries to do by default, it tries to make a column go downward from the floor that you're on. So here I'm on a level 1. It actually wants to make the column go down below level 1 and then come up to level 1. Now, typically as architects, even when we're putting in structural columns, we're actually wanting those columns to go up like our walls do. So one of the first things that you'll have to do when you're putting in structure is when you're using the column tool, switch from depth to height so that the column goes up to the next floor. So there's the column. Now, if I didn't do that, this is what would happen instead. Revit would make that column go downwards, and you're going to notice the column doesn't appear at all. And that, again, is because of our view range settings. The column comes up to the bottom of the floor, but Revit still doesn't see it. So even if you just make your view depth -1 foot, at least we can see that the column is coming into the view. So by default here, here's the 2 columns I just placed. So you can see by default, Revit wants to make the columns go down. You will need to, when you put in the column, just make sure that you specify height instead of depth for that column. So again, just a simple case of using the structural column tool and then switching to height mode. Another thing that's a little different between architects and engineers is the continuity of load-bearing structure. If you have a multi-story building, an architect will put a column in, even a structural column, especially if it doesn't change size, as like a 15-story column. So let's say you're putting a concrete column into a building and you've got like 5 to 10 stories where that column is the same size. An architect will just draw that column as going up 10, 15 stories. But as you folks may know, structural engineers consider that columns only span from floor to floor, because at each connection between a column and a floor plate, you have a point of pivot or a moment connection where shear forces need to be considered as if the building shakes, where that column intersects the next slab above, you're going to have some torque forces that are getting generated around the top of that column. So structural engineers really need to think of those columns as single-story objects, not multi-story objects. But for planning purposes, when you folks are trying to get a bunch of columns worked out in a bunch of floor plans in a multi-story condo tower, having separate sets of columns on each floor would just be miserable. It'd be a horrible thing. So as an architect, it's totally fine to draw a column that is the same size and spans multiple stories as a multi-story column. Don't worry, don't let that bother you. And if you were to ever hand your Revit model off to a structural engineer, when they bring that model into Revit Structure to do their structural engineering model, Revit Structure will help the engineer break that column up into single-story columns instead of a multi-story column. So you don't have to worry about that. Okay, so let's talk about structural columns then here, page 2 of the notes. Okay, I'm just making sure here that I don't lose my chat here. Just a second. Okay, so you know what I actually have to do here? I have to I just have to close Revit for a second here. Actually, I don't have to close it. I just have to make sure that there's no files open. Okay. Okay, structural columns. So Revit has the concept that when you add columns to your project, that you will do them at grid lines. So I'm going to just simply draw a series of 6 columns here, 6 grids rather, 3 in each direction, just for this exercise where we are talking about column placement. So when you go and find the column tool from the structure tab and you switch to height mode, when you put your cursor on a grid, you'll see that Revit just wants to clunk, put that column on the grid. And if you get to a grid intersection, Revit just, everything turns blue, because Revit is like, hey, you really do want to put that grid at a grid line intersection, don't you? Revit's really kind of trying to coax you or prompt you into going down that road. And of course, that is standard practice. So when you are at a grid intersection, if you just simply click, you will have that column placed at that intersection. If you hit the space bar, it will rotate the column through 45 degrees. And if you're left-handed, you'll see it rotate counterclockwise. And if you're right-handed, you'll see it rotate counterclockwise, right? I don't know, whatever that thing is. So now the reason for the 45 is that often for bracing purposes, a steel building will have columns on the 45, especially to deal with corners. So just hit that space bar, you can get the column orientation the way you want, and then left click to place it. So you could go through to the next column, place that one, and then place the next one, and just keep on working your way around. But if you are truly placing grids at each one of your grid intersections, there is a faster way. If you're using the structural column tool, there is an at grids option. Now, then what Revit wants you to do is to select a bunch of grids that are intersecting. So if I just select a bunch of grids, I don't get columns. But if I select intersecting grids, let me zoom in here so you folks can see. So as soon as I select an intersecting grid, Revit ghosts in columns at all of those grid intersections. And if you like it, you can hit finish. So if I were to crossing select or window select all of these grids, I would see columns ghosted in at each one of those intersections. And if I hit finish, I get columns in all of those places. So there's the columns that just got added. Now, after you've placed a column, you can come back later and click it and hit the space bar, and Revit will rotate it through 90 degrees. It's only when you are placing a column for the first time where you can get it to rotate through 45 degrees by hitting the space bar. After it's been placed, it rotates through 90. And I just realized I didn't set all of these columns to go up to the next floor. There we go. Okay. So now I've got all my columns in there. You folks can see them. They're stretching up to the next floor. Now, quite often with structural columns, especially steel, when we're putting them into a building, that it will go from one floor to the next, but often these columns will go down through the slab to under a slab to a footing below the slab surface. So it's quite common for these columns to go down an extra foot downwards below the slab. So much like a wall, you can specify a negative base offset for a column if it's going down to a footing that's going to be below the floor slab. Okay, now, if you were putting in a sloped column, there is a way to do so. So here we've got our sloped column instead of a flat column. With the sloped column, The 2 clicks that you use to place the column represent the horizontal offset between the bottom and the top. So here we can choose the height of the first click. So here I'll say it's right at level 1. And then I'm going to say that the second click takes the column up to level 2. Okay, so now we'll talk about 3D snapping in a moment here. So now I can just click somewhere in my drawing, and now there's going to be a 10'6" horizontal distance between the bottom and top of the column. So let's go look at what this thing looks like in 3D. So there's my sloping column right there. I'll just turn on shading. It's a little easier to use. So here you can draw a sloping column. Now, if you want it to snap to something, if you've got a beam that's out there, we'll talk about how we can use 3D snapping in a moment. Now, we should talk about the workflow for structural object creation in a project. So typically, Revit will want you to place the columns first. So you put in your grids, then your columns, and then the beams that are supported by those columns, and then the structural decking or the whatever elevated floor assembly that's going to be supported on those beams. So grids, then columns, and then beams between those columns, and then your joists being supported on those beams. So that's kind of the general process by which structural objects in Revit are drawn. So there is an order to all of this. So once you've got your beams in place, and so again, you're going to draw these things from story to story. So if we have a 3-story building here, I'm going to put in a few more stories. And I'll put in a roof as well. So there's my roof. Okay, so I've got all of these stories now. So if I wanted to draw columns, not just from level 1 to level 2, but also from level 2 to level 3, you know, you've got your options. You can draw your columns multiple stories, or you can draw them on a single story basis. So on the second floor here, I'm just going to start drawing in these columns. Now, there's something to keep in mind here. Level of detail becomes more important with structural engineering objects. If I turn on thin lines mode here, when we're looking at a column, it looks like the columns don't actually have any thickness. But wait, once we get into medium mode, you folks can see, hey, now we've got the actual physical thickness of these flanges. So with structural engineering objects, coarse, medium, and fine actually have a pretty significant effect on the appearance of structural engineering objects in Revit. So here at the coarse level of detail, we only get 2D lines. This is just 2D geometry. It shows up with a heavy line weight, so it looks pretty substantial in your drawings. But at the coarse level of detail, these are just thick lines. Now I'll turn on thin lines again. At the medium level of detail, we see the true dimensions of our columns and any other structural engineering object as well. So open web steel joists, all kinds of objects, they do look a little different as you go through these different levels of detail with the scale. Now, as we go to fine, have a look at what happens here at the corners with the fillets. The fillets show up. Okay, what's going on here? What is in these structural columns, these steel ones? Well, ladies and gentlemen, there's actually 2 different solids in here. There's the one solid that shows up at the medium level of detail without fillets. And then at the fine level of detail, Revit turns off that simplified geometry and turns on this more complex model. Now, I always find that a bit mind-blowing. There's actually two different columns modeled in a single Revit structural column. Now, the one, of course, that's not 3D geometry, that's 2D geometry. But at the medium level of detail, Revit shows you one solid model that it has created without the fillets. And then at the fine level of detail, that's actually a totally different solid that's in there. And you're like, well, why couldn't they just add the fillets on there? I don't know. So just so you understand how these things are behaving. So there's other structural objects that have the same thing where between medium and fine, they do show extra geometry once you make the switch between those different levels of detail. Okay, it's 7:30. Let's take a 10-minute break, and we will come back right away at 7:40. Okay, so we are going to move on to talk about beams now. Now, beams in Revit, it's actually a pretty wide variety in terms of the kinds of geometries and objects that we would build. So let's get into some of that stuff now so you guys can see what these objects are. So on the structure tab here, we've got the beam tool, and the kinds of beams that you can have in Revit, we're going to look at those now and the library of the structural objects that Revit provides. So whether you are using the column tool or the beam tool or one of the other tools, but predominantly columns and beams, Revit has a substantial library of these objects. So what you got to do, you got to go down into the structural folders. And so this is a beam. It's not a column, so we're using the beam tool now so you folks can see place beam. So you got to remember to keep your head on your shoulders and not accidentally go into the structural columns folder. You know, I've done that so many times. You know, you go into it, you're not paying attention, and I've started up the beam tool, and then I go into the structural column folder to find something. Like, what? Wake up, dude. So structural framing. So Revit has concrete, steel, and wood and precast concrete structure for you to use. Now I'm going to go into the steel folder here, and Revit has all kinds of stuff here. So here we've got open web steel joists. I've got channels, double channels. We have the W beams down here, right? Wide flange, heavy duty steel joists that have a sloping top chord. Like, there's a lot of stuff in here. And of course, there are other proprietary structural engineering objects that you can get from various manufacturers to use in your Revit model. So if I just grab a couple of these things here, so I'll grab the K-series bar joist, and that's funny, Siri thought I was talking about her K-series. Oh, of course, a K-series bar joist. Yeah, there it is. I just Siri thinks needs me. So I'll grab these different objects here, and then we'll see how they can be used. Now, with many of these structural engineering objects, when you load them up, Revit has a catalog of different sizes for these objects. So, you know, if I want to grab the 16-inch bar joist and the 18-inch and the 12-inch, you can see I'm holding down the control key to add these into my model. So now all four of those will be loaded into my project. The quiz, folks, that'll be open book. You guys can do that over the next week. So you have 2 chances to do the quiz, and you got 2 hours to do the quiz anytime you want over the next week. It just has to be done before next week's class. Okay, so putting in beams into your project, so you should have your columns in place first. So I like to put my beams into my project in 3D because then I will be able to use 3D snapping. So with 3D snapping enabled, when I'm in 3D, I can take my cursor and it's going to snap nicely to the top of a column. And then I can go to the next column, and Revit's very, very clearly going to show that my column has snapped from, or my beam has snapped from one column to the next. So here again, just pay attention to the tops of your columns, and you can see Revit is putting all this geometry in. So I can just go from, I can do chain, column to column, column to column. Sometimes if you're trying to begin and end a beam on the same column, it's kind of grumpy. Now, I think the reason that I can't start the beam again here is because I've got this control for the first beam I put in that's still visible. If I zoom in a little bit more, yeah, now I can do it. I can just keep going. So just like a wall in Revit, all of these objects are really just placeholders. If you need to put in a different kind of structural object after the fact, go ahead, click on the object, and then you can grab one of these other kinds of structural engineering objects, and there's now a open web steel joist that's spanning between those objects. Now, again, keep in mind, level of detail is a big deal. Coarse level of detail, look what we get. Sticks for the columns. And then just an outline for the open web steel joist. Now that is by design. In a structural engineering drawing set, quite commonly, that's how you would expect to see these objects in the plans. So if we go into the plan view here, actually second floor, if I go to coarse medium detail, I'm just going to see thick lines. Now the reason we're not seeing anything here, folks, again, is because of view range. Remember that our architectural view range only goes down to the floor level. And of course, the beams for structural engineers, you know, they're below the floor. So we've got to take our view range and add that extra foot down there. And there you go. That's what a structural engineering floor plan would look like. Heavy lines between the columns. Now we go to medium level of detail. Now we're actually seeing the physical size of those columns and those beams. And at the medium level, or fine level of detail rather, we're getting to see those fillets. And of course, the same was true in 3D. Coarse level of detail, medium level detail. Look at the joist though. The webs are still just 3D lines between the webs. I go to the fine level of detail, and now we actually see the full geometry of these objects. So these beams can just be placed in 3D. And so in the notes, it says at the bottom of page 2 here, if you want to see those beams after you've placed them, you know, in a floor plan here. So let's say I want to see those beam locations that I've placed in 3D. So here, and I can snap, 3D snap from one beam over to the other here. So you can see I did a snap perpendicular there. So I'll just do a couple of beams here because I just want to note that, you know, if you're in a floor plan and you would like to see those beams overhead, don't forget about the underlay feature. So you can do an underlay of the floor that you are on and ask Revit to look up. And there's those two beams that I just added moments ago. So it's a good way, you know, if I want to draw some dashed lines in here because I want to indicate where those beams are in my floor plan, that underlay can be super helpful for setting that stuff up. And then after you've gone through the process of putting in those dashed lines, you can either use detail lines or use the line work tool, right? So if I want to show where overhead structure is at, I can use the annotate tool and throw on some detail lines, throw on some hidden detail lines, and just pick the edges of my structure, right? So now, I'm going to see dashed lines in my floor plan where those beams are. So detail lines, you can just draw those on top of the structure, or, and this is slightly more dangerous, but it's also slightly more automatic. If you're on your own, you can use the line work tool. If you're working with other people in your office, you might just want to talk this over with your team. Line work tool. So what I can do is I'm overriding the edges of the beam. So instead of just being a gray line like we see here, I'm overriding it to show dashed lines like I did with these detail lines up above. So this is detail lines, this is line work tool. Now after I'm done picking the edges of the beam or drawing the edges of the beam with detail lines, I'm going to go back and turn this underlay to none. And all that structure disappears. Now, what's the difference? Well, here, look what happens when I pass my cursor over these dashed lines. I'm actually selecting the object, the structural beam. Whereas up here, oh, these are just 2D lines, and I can delete them without any consequence. The cool thing is, though, that if the beam were to move, those dashed lines would move automatically. That is the power of the line work tool. Problem is, what happens if somebody deletes those lines? They delete the beam. Can I get rid of those lines without deleting the beam? You sure can. Use the line work tool again, but use by category. Now, what does by category mean? Well, it means how object styles would define how that object appears in this view. Okay, how does object styles say that a structural beam should appear in a floor plan if the structural beam is like above you? How would object styles ask for a structural beam that's above your view range to show up? It wouldn't. It'd be invisible. So if I go back and make my dashed beam lines by category, it means it's just going to hide them. They're just going to go away. There you go. So now my beam, there's no more indication of it in this view, and those dashed lines have gone away. So it's up to you. But if I'm going to show my beams in a floor plan on my own, I absolutely will use the line work tool. It's so nice that that is automatic. Okay, on to page 3 here. We're going to talk about beam end handles and shape handles here. Now, to really show this off here, I'm going to what am I going to do here? Okay, I'm going to click on one of my beams here, and you folks will notice that there are 2 sets of controls. There are triangular handles here, which you folks can see, and I can drag them back and forth like that. Also, there is a circular handle, which I can drag back and forth as well. So what is the difference? Okay, so the circular dot is as far as Revit's concerned, the actual end of the beam, the structural end of the beam. So what's happening with this beam? This beam is carrying loads over to this column. And basically Revit says, yeah, the loads from the beam are being transferred to the centroid of our structural column and then down to the ground. So these triangular handles are called the shape handle. So in this case, if you want to show a non-structural cantilever of this beam, you can drag this thing out past the other side, and that will allow you to extend this beam. So Revit calls these things cutbacks. Now, sometimes we will have a cutback just so we can get some structural engineering stuff here, like a plate and some bolts. And Revit calls that the structural join cutback. So you can see it here. It's an 8-inch right now. I've got an 8-inch cutback. So I can specify a specific cutback if I want. Now, if you extend your beam past the other side, Revit calls that a negative join cutback. So you can do this to do a cantilever of a beam past its end supports. Now, should the beam sit on the column, or should the beam hang off the side of the column? I don't know. That is a structural engineer's purview. So if the structural engineer says yes, the column is to sit underneath the beam, if that's the case, then I would stretch my beam over, and just like we can do with walls that are underneath the roof, you can click on a column and you'll see attach, much like you would with a wall, and then pick your beam, and it's going to, well, I've got to unjoin them here. So I'll just redo the beam because I've been playing around with it too much. Okay, so pick the column here, choose the attach button, pick the beam. I got to pull this join away. There we go. So you see the round dot there, I've got to pull that away. There we go. So now you folks can see that the column goes up to the underside of the beam. So whatever your structural engineer says, that's supposed to go, then you can decide that when you're modeling this stuff together. Okay, so now if you were doing steel structure in a building, or if you wanted to do a whole bunch of layout of some wood purlins in a project, you certainly could in any given view here, whether it's a plan view or 3D like I'm doing here, you could grab the beam tool, then you could go and find a particular joist that you want to use, and you could 3D snap all of the joists that you want in a given base. So there's my open web steel joist. Going to the next one here. Right, so it wouldn't take too long. But Revit actually has a slicker way of getting joists arranged in a structural base. So that is in an area between 4 columns that are supporting an area of floor. So let's look at that instead. So that is called the beam system right here. So we're going to look at that next. Okay, so actually what I'm going to do here, I'm going to finish off all of the structure around this corner. Okay, nope, wrong kind of structure. Alrighty, so let's say that I want to put a bunch of open web steel joists spanning across from this beam to this. How would I set that up? Okay, so here I am in the second floor plan, and I want to put my joists spanning between these 2 beams. How's that work? Okay, we're going to be using a structural beam system here. And structural beam systems are kind of a funny thing, because you can't make a structural beam system that has a defined type to it. Now, what does that mean? Now, you folks know that you can make a wall type that's 2x6s. It's got so much insulation. You got gypsum board on the inside. You got whatever finish on the outside. That's a wall type. And anytime you want, you can go grab that wall type and place it somewhere in your project. But when you fire up the beam system tool, you have to define the joists you wish to use. You have to define their spacing every time you use this command. So Over on the properties palette here, like normally where you'd see like 2x6 wall, exterior, blah, 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 there isn't anything. Like I said, there's nothing in the type selector. So you can't save 2x10, number 2, fir joist at 16 inches on center. That's not a thing. You can't save it as a thing. So I have to go in here and I have to choose how I'm going to space the joists, all these options here, what actual spacing I want between them, how I want the joists justified within this bay, and finally, which joist type of all the structural engineering beams that or joists that I've loaded is the one that I want to use in this bay. Now, there's two modes: automatic beam system, sketch beam system. The automatic beam system is nice and fast. You put your cursor in the zone. Now you put your cursor on one of the four structural engineering objects, the 4 beams that span, and if you click on one of them, Revit will make it parallel to those members. So I want it parallel to this guy here. So again, choose your justification, beginning, center, or end. Pick one of the beams to indicate the direction you wish. And there we go. There's all of my my open web steel joists. And this is pretty cool. Now we're going to talk a little bit here about steel construction and just how you need to arrange all of the steel structure on your project. Now this may not pertain so much to wood frame, but with steel there's certainly a definite order with which everything needs to be arranged. Let's talk about that. So I'm just going to cut a section here. So I got a section that's going to be cutting through our steel structure. And I'm going to set my level of detail to fine here so I can really see the geometry. Okay, so there's lots that is wrong with this picture. When we have an open web steel joist, it does not come up to the level of our floor. It sits below our floor. And in fact, typically for steel structure where there's a steel decking carrying the concrete, you have a 4-inch slab. So you got an 1.5 inch undulating steel decking, and then 2.5 inches clear concrete on top of that. So at the bottom of the flute, there's 4 inches of concrete. At the top of the flute, there's 2.5 inches of concrete. So that's pretty typical in the Vancouver area. So yeah, we can start putting in the structure, but let me just model this floor here. Now I think out of the deck, Revit has a concrete on metal deck. It's not 4 inches though. I think it's, oh, it's 5. Okay, so whatever, I'll use that. Now I'm just going to draw it in as a rectangle here so that our concrete floor is right at the level. So there's our concrete floor. So you guys can kind of see what's got to happen here. Our joists, they need to be underneath that 4-inch thick floor assembly. So actually when I'm creating this beam system, and when you put your cursor in 3D over the beam system, you may see a series of dashed lines that run around the perimeter. That is the beam system itself. So if I click it, now I can deal with the properties of the beam system. So I can change the joist spacing. I can change the joist that's being used. And right now, importantly, I can set a Z offset so I can drop it 4 inches so that the beam system is now going to sit underneath the slab. So you folks can see what's happening there. Now, let me change the scale here so this makes it a little easier to see. There's my open web steel joist. As you folks may know, open web steel joists have a seat at the end. Let's go in 3D here and just have a look at this. So there's one of our open web steel joists, and it's got a couple of these little metal sort of C-shaped channel bits here that form the seat of the joist. So the bottom of that seat is supposed to sit on a beam. And then the top of that seat, well, that's the top chord of the open web steel joist, and the decking spans in between the open web steel joists. So those seats are 2.5 inches for smaller joists and typically 5 inches for larger joists. So in section here, we've got a problem. This beam is sitting way too high. So it looks like we've got a 2.5 inch seat here. So we've got to drop this beam down 4 inches for our floor, and then another 2.5 inches for the joist seat. So in here, we can specify a negative 6.5 inch Z offset for that beam, and now it's sitting at the proper elevation. So I just did a reset there, and you folks can see that indeed our steel beam is sitting at the right height. So when you folks are putting the steel structure into a building, if you're going to model that, then just keep in mind where all of these different bits and pieces sit. Now, if you don't know initially, you can kind of take your best stab at it, or you could call up your engineer and say, hey, listen, it's going to be open web steel joists. If you do a lot of steel buildings, you'll know if it's going to be a 2.5 or a 5 inch seat depth for those open web steel joists, and then you can design it accordingly. So on the one side where the beam is directly supporting the joists, you're going to drop for the seat. On the other side where the beam is simply supporting the edge of the decking that's coming to that end, because the beam is running parallel to the joists at the end of the bay, well, in that case, then you only drop this thing down by the thickness of the slab. So the Z offset value here, minus 4 inches. When you've got a beam selected, by the way, you'll notice that there is a numerical value that's displayed on each end of the beam. So what these are numbers so that if you want to vary that end of the beam compared to the other, you can do so. So here, if they're just 0, it means that the structure is going to be flat. But if you want to specify a specific number, you could do that if you want one end to be 6 inches higher than the other. Okay, now with these beam systems, there's a fair amount of flexibility if you need to put something in like an opening. So I'm just HHing the floor right now so that I can see in here. So here's the other beam that I need to drop minus 6.5 inches. There we go. Now, when you put your cursor over a beam system, sometimes you may get the beam system, or sometimes Revit will give you just that one joist of the beam system. Now you'll see that it's pinned. So Revit's just saying, hey, the definition of this object is not something that you're really meant to change right now on its own. So what you got to do is put your cursor kind of around the perimeter and hit the tab key until you see that dashed blue line. So I had to hit the tab key twice. So again, let me hover. Hover, 1 tab, 2 tabs. There's the beam system. So now I can click to select it. So now I could go in and make the changes that I want. So if I want to change the spacing of my joists, I can do so. Now, if for whatever reason you need to modify the spacing of maybe just one joist, you certainly can click it and unpin it. And now this joist will be able to be changed in terms of what kind of a joist it is, or you could move it around if need be. So here I can go to my second floor plan. And just for a moment here, I'm going to HH the floor so it's out of the way. So I can grab one of these joists. So here's the one that I unpinned. And now I can move it a little bit from side to side if necessary. And if I want, I can copy it. So if in one location here, we need to increase the spacing of the joist, or decrease the spacing of the joist rather, to carry something in the middle there. So maybe there's some heavy equipment. And so the engineer wants us to tighten up the spacing on the joists. You can unpin one of those things and move it and or copy it if that's what you need to do. Where are we at here? 10 after. Let's just take a 5-minute break here. So at 10 after, let's come back at 8:15 and we will carry on. Okay, so after you have been working with the beam system and perhaps you have made some changes to your beam system and you're like, you know what, can I just get it back to where it was initially? So what you need to do is select the beam system. So again, you can kind of move your cursor around until you see that dashed blue line that represents the beam system definition. Or put your cursor over one member of the beam system and hit the tab key once. So that was just a hover tab click, hover, tab, left click. So now I've got my beam system. So if I hit edit boundary and go into, as if I was going to move those pink lines around, there's a reset system button, which will take all of the changes that I've made and undo them. Now remember, I copied this extra joist, so it's not part of the beam system. It's just sitting there, so I can delete that. No problem. Now, this beam system, of course, was placed in my level 2 plan. So the beam system itself, if I look at its properties, hover, tab, click, you folks can see the work plane, level 2. Now you can choose work planes on the fly. Let's make an example here. I need to go into one of my elevation views here and stretch my grids up. There we go, so I can see them in my roof plan. So what I'm going to do here on my roof plan is I'm going to just do a roof that is sloping, perhaps on a somewhat arbitrary angle. So I'm going to do a footprint roof, and I'll give myself a 4-foot overhang. And I'm going to slope using the slope arrow tool, and we'll see that in a second here. So there's my roof. So I could be really simple and pick one of my roof edges and make it slope defining, but instead I'm going to use a slope arrow, and I'm just going to slope on some angle here. There we go. And so yeah, this is what that's what my roof is doing. It's kind of sloping on a bit of a crazy angle. So on the outside of the building, that could give you kind of a nifty shape on all sides. Now, what if we need some structure up there to support this? So we're gonna build some open web steel joists, or maybe we'll have some W shapes that are going to be, up here on the bottom of our building. Well, what we can do is we can specify that this is our the plane where we are going to be putting some joists, or we can change the work plane later. So with our, let me just tab select the joists there, so you can see after the fact, you can choose edit work plane, and then you can choose pick a plane. And I do believe we can just pick the bottom of, oh no, that doesn't work. I have to start that way. Okay, so we're gonna start by setting our work plane so that we are going to add steel structure to the bottom of this roof. And you can see it's not, right? Like it's, this is not a straightforward bit of geometry in terms of where this roof is angling. So in 3D here, I'm gonna add this structure in. Okay, so I'm going to go back to the structure tab here. I'm going to do a beam system. But now before I start defining my beam system, I'm going to tell Revit straight away that I want this geometry to be hosted by or to sit under the bottom of this roof. Now here, let me switch to hidden lines. It'll be a little easier to see. There, you can see I'm picking the underside of that roof. So my beam system is going to go on the bottom of this object. There we go. So now I'm going to choose what kind of, I'm going to use W-shaped steel. And I'm going to pick the edges of the roof. Now, when you're putting in these beam systems, one of the four sides of the sketch for your beam system is going to have this double line that's alongside it. This basically specifies what direction the structure is going to span. So in this case, if we want our joists to span in that direction, that's great. If not, there's a beam direction tool here. So you can pick one of the other sides and have the structure span in that direction. So that's up to you. Now, I don't want my structure going right up to the edge of the roof. I'm going to offset it in 4 feet because that was my roof overhang. So back to the modify command here. Where's offset? Offset, 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 offset. Right there. Okay, so I'm offsetting 4 feet. And I'm not copying. I want to just move it back into the inside of the building. Hover, tab, click. There we go. So set my spacing that I want for my roof structure. And once I'm happy, hit finish. And there you folks go. Now you can see that structure is hugging the underside of the roof. So it's a really slick way that these beam systems can be used to be put on any plane. Now, the last little bit here that we're going to talk about with regards to placing beams. So far, we've been putting beams on in plan, and we've been putting them on in 3D. Now, we're also going to put a beam on now in elevation. So let's go to one of these elevation views here. Now, what I want to point out here is that I'm going to place a beam on grid 6. So that's where this next beam is going to go. And I'm going to put it on in my south elevation. So this is similar to when we put on an extruded roof. Now, if I want to draw a beam here in this view, and I want to draw it in elevation, I need to tell Revit which working plane, front to back, like depth-wise within this elevation view, that I want the beam to sit at. So already I knew coming into this that I wanted to put my first beam on grid 6. So what I can do is I can go to the set work plane command before anything here and go and choose grid 6. And so this is telling Revit in advance, okay, this is going to be our work plane for whatever we're going to be doing in this view that might use that kind of information. All right, so grab the beam command. And now whatever I draw is going to be in that plane. So let's say that I want to do a curved roof instead of this sloping roof that you see right now. So if I want to do a curved beam, like a curved wood beam or a curved glulam, here I'm doing curved steel, so whatever, I can do that. So here I just do a multi-point arc. So there's my curved steel beam. And so now this beam is sitting right on grid 6. So if I go to my east elevation now, there's that beam on grid 6. So if it's the same shape of the roof from one side of the building, well, now I can just, copy that beam right over across the building for as many of them as I want, and put in those beams. So here I'm just going to use the array tool because that's a nice fast way to get her done. So I don't know exactly what spacing that is, but when we look in 3D, you folks can see that, having placed that one beam into on grid 6, I can just copy the rest of the beams sideways, like you see in our notes about halfway down page 4. Okay, any questions so far? So one thing that we haven't touched on is the fact that Revit does, it does now allow structural engineers to specify the connector that holds the beam onto a column. So for a few years in Revit, you couldn't do anything more than what we're seeing right now. There'd be this weird gap between the beam and the column. So Revit did not yet have the tools to model the plate and the bolts on the end of this beam that would connect this beam back into the column. So now Revit's got connectors so that you can, you'd see coming off our column here, you'd see a plate that comes sideways. There'd be some bolts on that plate. So the plate would be welded onto the column and come sideways over to our beam here, and have the bolts securing the beam to the column with that gusset plate. So that is something that Revit can now do, just in case you're wondering. Okay, braces. So we're looking now on page 5. I'm just going to mention this in passing. Obviously, for resistance of structural forces, what we've got here isn't terribly great. We need some cross bracing. So on the structure tab here, we've got our brace tool right here. So those are typically done with, or quite often done with a HSS tube. So I'm going to go load one of those things. So this is a brace, so I got to make sure I go into the structural framing folder, not columns. So when you are loading a brace, make sure that you don't go into structural columns. Make sure you go into structural framing. Steel, so I'm going to go grab HSS. There we go. And I will grab a, let's see here, 4x4 tube. So I just got to roll on down in the list here, 4x4 by 3/8. Okay, so I've loaded that HSS tube in here now, so I can use 3D snapping. So I can snap, say, from the bottom of this column, and I can go up and 3D snap into somewhere along the column here. If I wanted to change it and make it so it's exactly 45 degrees, I could do that in elevation. So say in my south elevation view, remember that's grid 6 again. I think Revit might still remember that we're in grid 6. Yes, it does. So now I can do that brace, and I don't even have to use 3D snapping in this case. So I can go from whatever height I want the brace to sit at with regards to my floor. And now I can go up it straight at a 45-degree angle. I'll just keep on going up till my beam, and there's my brace on that side. So now I'll do another one over here. So I can start foot above the floor, look for 135 degrees, and keep going up until I hit my beam, 135. There we go. So now I've got my braces on there. And again, Revit can model these connections between the beam and the brace. Okay, so you saw me put this out of the box lightweight concrete on metal deck into the plan. I should note here, let me, we've got two sections here. So we've got the one section here that's going going across. Let's cut a section going in the other direction. Now in this view, you folks can see that you don't see, like, you see full depth concrete. Now let's look at the other section here. Now we're supposed to be seeing flutes. I don't know why we're not seeing flutes. Let's just see here. Oh, I used the wrong floor assembly. Okay, here's the one. This one's a little bit too thick. Well, let's talk about this. Now, here in this view, you folks can see there's something going on here. You got a concrete layer, and then below that, here's the floor layer. Well, let's look at the other section here. So this floor object, again, floor type is 3-inch concrete on 2-inch metal deck. You can see the flutes in the bottom here for the metal deck. 2-inch metal deck, never seen that. Either it's 1.5 inches or 3. Those are the common sizes that you see around here. So when you look at the section in the other direction, well, oh well, oh well, look at that. Isn't that nifty? It looks like Revit is modeling every single bit of flute, up and down, up and down, up and down, from one side right to the other. That's pretty impressive stuff. Okay. I wonder if we had a camera that was looking up at the underside of this, would we see those flutes? That's a lot of modeled geometry. Okay, let's look. I'm going to set my level of detail to fine, and just making sure, is that the deck or is that the floor with the, yep, 3-inch concrete with 2-inch metal deck. What the heck? Do you guys see any flutes? No, you do not. So what the heck is going on here? How is it that we can see the undulations of the steel deck in section, but you don't see it in 3D? That is because this is actually a 2D presentation. Now, you guys may not know this, but in your floor plans, when you see a wall assembly and you see a bunch of material layers in it, like this one here, you see those material layers? That is not 3D. Those are 2D lines added on top of a 3D object. Modeling all those different layers and then getting all those different layers to join as a modeling process would absolutely kill your computer. So all of this 2D geometry that you see in your walls and your plans, other than the inside and outside faces, all that stuff on the inside is 2D. So keep that in mind. So likewise, when we look at our sections here, Revit is just monkeying around and showing us a 2D presentation of this floor slab, which is incredible because, like you can see in the background there, it is showing a little bit more of that open web steel joist up inside the flute. Now, let's look at the properties of metal deck and concrete floors. So you guys hopefully have been in the structure dialogue quite a bit. Here's the deal. If you want to use metal deck in your project, you have to have a special kind of profile loaded into your project. Now, the out-of-the-box architectural template has a structural deck profile. And this profile is based on a family. So down here you can see there's a form deck underscore non-composite, blah, blah, blah. We would find this in our project browser in the profiles folder. There's profiles. And now we are looking for, there it is. Now, like I said, in Vancouver, we do not have, I've never seen it anyway, a 2-inch thick metal deck. So I'm going to rename this 1.5 inch thick, and then I'm going to go into its properties here. So I'm just right clicking on it, and I guess HR must be the thickness value. So I'll put in 1.5 inches. There we go. Aha, there you go. The deck got thinner. Now, this floor, that's too thick. So here you specify the profile that's being used. So there it is, 1.5 inch thick profile. And this is the clear depth of concrete that fills in the flute. So maximum 4 inches thick of concrete. There. So 1.5 inches of concrete dropping down into the flute, and then another 2.5 inches of concrete on top. That's typically to get you a fire rating. So I think there's a ULC rating for a lot of products that make steel decking for floors, and that gives you a 1 hour rating. So this 4-inch assembly with 1.5 inch steel deck is something you see quite a lot of in the Vancouver area, used for steel buildings. So load that profile into your project, and then once you find the family, go into its properties and set the depth here, which was the HR value, to give you the thickness of steel decking that's going to be used for your floor assembly, and then off you go. Okay. Let's move on here to foundations. Okay, so what I'm going to do here, let's just see where I am in 3D. It is kind of, what I want to do is actually add a little part of the building where I have some concrete walls. So I'm just going to add a little spot here off my west edge of the building, where I'm just going to have like a little add-on to the building that's going to be some concrete block walls. Alrighty, so let's get some 8-inch masonry here. There we go. And I'll make them go up to the next floor. So I got 1 story of masonry. I'm going to put some footings underneath this thing. Okay, here we go. Core face exterior. All right, so go out 10 feet. And then up to the other grid line, up here, and return. Okay, so got some concrete block walls here. So now I want to talk about putting a foundation underneath these walls. Now, keep in mind we've got some columns here that go down to 1 foot below our floor line, because typically with our steel columns, they don't just go down to the floor. They usually go down another foot below, so they can just put it right on top of the footing. So we might then also take our masonry or concrete walls and set them down an extra foot as well. So both of them will have footings at the same elevation. So first of all here, we're going to look at the wall fitting tool. Okay, so wall footings come in 2 flavors: bearing and retaining. Now, the difference between a bearing footing and a retaining footing is that retaining footings are what I'd call L-shaped. They're used on retaining walls. So you've got your toe length and your heel length. So this would be used underneath a retaining wall. So you've got one of these, like the heel length, goes back underneath the dirt of the hill, and then the toe length is how much that the footing sticks out on the downhill side of the retaining wall. So here, depending on the thickness of your wall, right? So if you've got an 8-inch thick concrete wall, this footing will be 1 foot, because these are both projection values. Toe and heel are both projection. So it goes 2 feet out on one side, 1 foot on the other side, then of course you've got the thickness of the wall itself. So that's what this one looks like this. So this is, there's your retaining footing right there. So you've got 2 foot here, from here to the wall. On the other side now, you've got 1 foot from the edge of the footing back to the wall. So it's 2 foot plus 1 foot plus whatever the thickness of the wall is. So that is your retaining footing. So I'll delete that now. The one that you'll probably use more commonly is the bearing footing. And with this one, you simply specify the width of the footing and its thickness. So placing this footing at the bottom of your wall is a piece of cake. Click on your wall. There's your footing. There's your next footing. And there's your next footing around the corner. So these wall footings go on real easy. Just click on the wall and there's your footing. Now pad footings, when you want to put them at the base of a column, there's your isolated footing right there. There actually isn't any loaded in the typical architectural project, so you got to go load one up so you can use it. So the first thing we got to do after firing up the isolated footing tool is to go load one into our project. So hit yes. And where am I going to go here? I got to go into my footings tool here. So there you go. The footing rectangular is what we use to create a pad footing. Now, it's not square. The ones that are provided in the pad footing that you load in, so if we go over and look at the properties palette here, and they're huge too, like they're ridiculously huge, 6 feet by 4 feet. So you got to go look at your structural engineer's drawing and find out what the dimensions are required for your pad footings, and then edit the properties here. So this is going to be 4 foot by 4 foot by 18 inches is fine, I guess. And then put your dimensions, width and length, 4 feet, and then your depth, whatever that needs to be, and away you go. So there's my pad footing. So I can just run around and kind of just drop them in the view. But Revit allows you to place them right at the columns. So when you click on the at columns mode, put your cursor on a column, and there you see it's going to put it on. So in fact, I could do a bunch of these things in 3D at once. So I can click the next one. I'm holding down the control key here so I can add these extra columns in. And I got to do these ones too. There we go. So 9 columns getting footings. Hit finish. Now, Revit recognizes that these columns go down an extra foot. So Revit puts our footings down at the bottom here, at the bottom of our columns. And look at Revit. It even joins geometry between the pad footing and the strip footing. Pretty sweet. So if you were to go back and look at your floor plans now, if we wanted to show those pad footings in here, we need to adjust our view range and make it go down another bit of distance here so that we can see those pad footings in our view. Now, if you wanted to, in a view, make those footings dashed, easy way to do that would be to go down and find your structural foundations and alter the lines. So I'll just make them hidden. So now structural foundations being shown in projection will have a dashed appearance. And why? Okay, good question. Why are we not seeing these dashed lines, folks? We'll pull up the view range. Why am I not seeing those dashed lines? Anybody? It's setting in a view range that's not allowing that category to appear dashed, even though, as you folks can see here, structural foundations should be showing dashed in projection. Well, it's in the view range, all right. The view depth right now is set to -2 feet. So that geometry is appearing. Now, I don't know how many of you folks took the intro course from me, but one thing I really make clear is about the beyond line style. Now, let's see how many of you remember the beyond line style. So if an object is below our view range, so here's our view range from top to bottom. So if an object is below the view range, but can still be seen by the view depth, Revit gives it a special appearance. That appearance is defined as the beyond line style. So I'm going to go into line styles here, and there's beyond right there. Anybody remember this? I did an example in the intro course where I show what happens if the beyond line style is turned orange. Now look at that. All of this geometry here turned orange. So that's a combination of, in the line styles dialog box, of beyond being turned orange, and the fact that in this view, my view depth goes down there, but my primary view range does not. Now watch what happens when I take my primary view range and make it so it goes down so that those footings can be captured within the primary view range. So as soon as that happens, now they're going to appear dashed. And that's because in this view, we'd ask structural footings, foundations, to appear as dashed in projection. Now what about those hatches there? Do I want to see those hatches? No. So my hatch patterns here, I can hide them. No hatches. There you go. So that's how you could get all of your footings to appear dashed in this view. So make sure your view range is able to see them. So in this case, the view depths in the bottom of the view range are set to be the same. So this means that the beyond line style won't have an impact. So if the bottom of your view depth, or the bottom of your primary range rather, if it is at the same depth, the same elevation setting as your view depth, then the beyond line style won't kick in, and you will only have whatever you've set in your visibility dialog box as a view override for this view. So I've done this on more than a few occasions of the projects that I'm working on. Okay, so that was our isolated and wall foundations here. There's our, I'm not going to talk about the slabs, that's no big deal. Let's see here, it is 8:45. Let's take another break here. Let's take a break until 9 o'clock, and then we will wrap up the evening. So I'm going to be looking here at page 6 and just giving you folks some general guidelines about these topics. Now, I'm just going to delete some of this geometry here. So slab plans. Now, when you folks are doing slab plans where curbs are required, so here I'm just going to take an example of, let me do an 8-inch concrete slab here. So I'm just going to make a concrete 8-inch slab here for the floor. And again, don't worry about, this is pretty straightforward stuff that I'm doing here. I might be doing it quickly, but I'm not doing anything terribly complicated. Okay, so often when a slab plan is being done for a project, it's because the shape of the building is complicated enough that a slab plan is going to be really helpful because the contractor really wants to know where the edges of the building are located. So in this case here, we've got our outline for the slab for the building, but we've also got some locations where there's going to be some balconies. So there's going to be some upstand curbs to prevent ingress of water into the building. So yes, those curbs could be drawn as walls. But man, oh man, what a pain in the butt to get all the walls to join nicely if you've got concrete wall curbs drawn. So I recommend highly that if you are doing a slab plan in the future, whatever height of curb you need, draw it as a floor object. So let's say that you need 6-inch curbs for your decks. So you need to have a 6-inch curb separating the slab outside from the slab inside. So what I'm going to do here, if I need a 6-inch curb, I'm going to make a 6-inch concrete floor object. So I'm going to take my 8-inch here and make one that is the height of the curb that is needed, and make a floor object that is that thickness. So if we need that curb over here for waterproofing purposes, so let's say this is the location where the curb is required, and then the next thing, of course, is you have to decide what the width of the curb is. So if it's a 6x6 curb, I'll just offset it 6 inches here. So there's my curb, and then I will just cap off the lines at the end. So the trick here is getting a floor object that provides the thickness required for the curb. And then the next trick is to elevate that curb by that same amount. So if you need a 4-inch curb, make a 4-inch floor, and then set its Z height above your level by its thickness. So what happens now is that this floor object sits on top of your regular floor object and acts like a curb. But this floor object isn't going to make your wall joints miserable. You can just draw your walls right up on top of this curb, on the curb, right into the curb. It doesn't matter. You'll just have way more luck doing a slab plan using floor objects as those curbs. Okay, so for sloped structure, we have an example file on the Learning Hub here. I'm just going to open it up here. So this is a very mundane example in many respects, but geometrically it's actually pretty complicated. What we've got is basically just a rectangular building. So this is like your tilt-up concrete. And quite often the structure inside for the floors and the roof is steel. So this is a non-combustible building. And often to make drainage work on the roof, they will employ sloped structures. So here we've got a beam that's in turn supporting our open web steel joists for the roof. It slopes from the roof edge down to a column that's at a lower elevation. So if we look at this from the side here, I'll just HH this wall on the end. You folks can clearly see how the structure is going up and down as we go across the roof from one side of the building to the other. So there's our undulating structure. So to facilitate this, here's the trick. I used 3D snapping to place those roof joists, and to give me something to snap onto, because usually with tilt-up construction, they place little pockets. They form little pockets in the concrete with a little steel plate in the bottom of that pocket where these open web steel joists will sit. So the pockets are made, the wall is tilted up into place, and then the joists are dropped down via crane, and the one end of the joist is slipped into the pocket here, and then the other end goes to the beam in the center of the roof. Now, I'm not going to bother modeling the pockets. That would be crazy. But to get the joists in quickly, what I've got here is a little 1x1 steel tube. And I modeled this all the way around the building. to give me something to snap to when I put in these joists. So these joists are not beam systems, they are individually placed because of the sloping structure situation. So to place these things, I use 3D snapping, and I had my structural engineer's drawings with me. So I knew the spacing that they were after, and usually have dimensions in their plans for the exact spacing that they want for each one of these joists in the roof. So I 3D snapped onto my HSS on the perimeter, and then came over and snapped onto my beam on the roof. Now, I'm not perpendicular here. I have no idea if I'm perpendicular or not. I could try to do a snap perpendicular here. Oh, there it is. Seems to be working. So there's my joist. So I could do that, but I just snapped onto any old place here, and I have no idea if I'm on the structural engineer's spacing or not. So how do I deal with that? Well, in the roof plan, I've drawn a bunch of detail lines. You folks can see these detail lines in green here. Those are what I use to align my roof joists that I drew in manually. So here's the one here that I just added. And I'll use the align command. Where is the align command? Go away, zoom interface, you're in my way. Modify, there's align. So I dimension the location of my detail lines here using the structural engineer's requirement for spacing for the joists on the roof. Then using the align command, after I've 3D snapped the joist into place, use align, pick the detail line, and coarse level of detail, my joists appear as lines. So there's the center of my joist right there. So pick the detail line, pick my joist, and boom, when I go in 3D to look at what I've done, wrong project, there we go, my joist, this is where it was before, and I just aligned it into place so that it goes right there, right where I want it in the plan. So that's the pro tip on placing structure in first. Okay, now we are going to talk about the massing tool set next week, and talk about how we can get our building's structure to deal with this. Maybe not structure so much, but with the roof object itself. Now, if we think about what's going on with our roof here, folks, on one side here, or on two sides, my roof, if it sits on these joists, on one edge, the roof is flat. On another edge, the roof is sloped. So that's a really tricky thing to deal with. So when we have sloping structure, trying to model a roof object that stays on top of all this undulating business, it's pretty tough. So we're going to use the massing tool set next week to discuss these scenarios. Now, what we're going to talk about next is levels of detail. Now, here is our plan. Here is the section. Now remember that at the coarse level of detail, all we see are sticks for the columns and a pretty simple outline for the joists. Now, you probably know by now that if I switch to the medium level of detail, I'm going to see more geometry. Now, for my webs, I'm still only going to see lines. So if I want to see something more interesting than that, I may want to switch to the fine level of detail where I really get to see how this structure is going to look in my view. The only problem of that is that we might be at a large scale where it would begin to show the material layers in our walls, floors, and roofs, and that may not be what we want graphically out of our view. So instead of turning the whole view, depending on the scale, you may not want your level of detail set to be anything other than coarse, right? So at 1 to 100, coarse level of detail, that is what you'd want to see. So instead, go into your visibility dialog box and go down and find your structural categories. Click the first structural category, shift click the last structural category, and change the level of detail to whatever level you want. So here I can force these categories to be fine while the rest of the categories are coarse. See a question about the quiz. It's you guys can do that during the week. It will be available on the Learning Hub as soon as class is done. So it's all good. Okay, so that is that's our tip. So now we're going to do a little exercise where all of us are going to build a little sort of pagoda thing starting on page 8. So if you guys want to download this file here, it's called the wood framing exercise. Structural wood framing exercise. At least I think that's what it's called. I'm just going to check on the Learning Hub here. Yeah, structural wood framing exercise. That's the one that we want. And okay, away we go. So what we have here, and I'll just turn on shading so it looks like the notes. We're going to put in some beams and we're going to model up the timbers to support a sloping roof. Now the roof is here. I've just turned the category off. So that's what the roof looks like right now. So what we want to build is the rafters and the beams that are going to support this roof. So this is going to be a heavy timber affair. So this roof that's sitting on here right now is wood purlins and the or wood decking, and then whatever the roof finish is. So we've got wood purlins, and I think it's just wood shingles. Yeah, so wood shingles there. So the roof is off, so we can kind of see what we're building here. And so I'm going to walk through this exercise with you folks right now, starting with number 1. Okay, so on the structure tab here, we're going to use the beam tool. And so it says use the beam tool and choose the 5.5 by 15 inch wood beam. There it is there. So it's 5.5 by 15 wood beam from the type selector. On the options bar, choose 3D snapping, which it is. Okay, so what we're going to do is draw the beam from end post to end post on the opposite side, and we're going to do that. We're going to do 4 of them. So like so, to there, and here, to here, and it's going to draw all 4 of them. It should only take you about 10 seconds. There we go. Now, the beams are in fact passing through each other. That's no big deal. We'd sort that out on site somehow. That would get resolved. There would probably be like some beam hangers that would be put onto the posts, onto the columns. So now what we're going to do, we need to get out of the beam command. So hit escape twice, and we're going to control click all 4 beams so that they are selected. So you can see control there. And what we need to do is we want to make an overhang for these beams so they extend outwards past the columns on all 4 sides. You need to go into the properties palette here and find the end extension. Yeah, here it is here, end extension, that one. And put in 4 feet. And that should make the beams stick out. Now this particular beam has been modified. Now why isn't that one? This is the first time this has happened to me, folks. Okay, I'm not going to worry about it. I think this may fix itself in a bit. These beams have some special geometry in them so that we can put notches in them. So with all those beams selected, I hit the check boxes for notching each end. And if your beams do what mine's doing here, don't worry about it. I think this is going to be fixed in just a few seconds. All right. So what I'm going to do here is I'm going to go to the south elevation. And you can see the roof is visible. All of our beams are selected. And so now in step 3, if your beams aren't selected, then go through the process of selecting all the beams as it suggests in point 3. And here's what we're going to do. Going to use the move tool right here, move. And you're going to do this. You're going to move the beams upward by their depth. So we're going to start here and move up to here. Move those things up. Now I'm just going to check in 3D. Yeah, look at that. Still doesn't want to muck about. I'm going to put, oh, it's a start extension, folks. That's what I forgot to do, for crying out loud. See, I did the end extension 4 feet. I forgot to do the start extension 4 feet as well. There we go. That's better. So start and end 4 feet. Make sure that that has been done. So now that we've got the beams in place, what we're going to draw is the beginning of the roof rafters that are going to arch or slope underneath our roof. So here in the south elevation now, we're going to build our first rafters that follow the underside of our roof plane. So we're in the south elevation, but we're going to put these rafters on grid line D. So here, south elevation, looking upwards, the grid D is where we're going to draw our first rafters. So if you remember, we talked about drawing structure in elevation. That's what we are about to do in the south elevation. So now we need to tell Revit what plane we want these beams to be in. So on the architecture tab or the structure tab, you go to the set work plane command. And with any luck, you will already be in grid D. So this file is obviously set up to make your life as easy as possible. So now, step 4. Okay, so back to the structure and beam command. And it says here, make sure 3D snapping is unchecked. And the reason is, we don't want our beam snapping willy-nilly to some part of the of this roof object. So 3D snapping has to be unchecked. So now we're going back to the beam tool here again. And we are going to choose different type here, 2x10 full sawn lumber. Now, I guess we can start drawing them. Now, some of you may find here that when you are placing or trying to place your beam, that you won't get snaps. So if you just go up and check and uncheck 3D snapping again, that seems to refresh it. And then, okay, see, look, it's not working. What did I just, oh, I had to go back and pick the beam type again. So if I go back and pick the beam type again, no, it's not working. What did I do? There was something that I had to do here to make the command work. Maybe I just had to go back and select the command again. Yep, I just had to restart the beam command. So if you don't get snapping here with 3D snapping unchecked, no problem. Bail out of the command, hit escape again. Go back and grab the beam tool, and then away we go. So we're going to be in chain mode. So we're going to do this. We're going to click from here to the peak, back to the eaves again, in one go. Click, 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 then hit escape. Now, with any luck, you should get a miter right at the middle. So that's really important. We want that miter because it makes the structure look really pretty. And we want pretty structure. That's what we're trying to do here. We're trying to do a really cool wood frame demo here. Now, the next thing we need to do is to get the notch done here. So there's these check boxes in the properties palette when you select one of these rafters that if you notch it, see, it's notching the wrong end, so I just got to switch the boxes around here. There we go. There. So I've got my rafters notched the way I want them to be. So you guys can see it here in 3D, nicely notched. Okay, so now we are step 5. Open the underside of beams ceiling plan. So in our ceiling plans here, underside of beams. So this view has been set up so that we can see, there's the 2 rafters we just put on grid D. Now, one thing here to note, the view range is such that it's actually chopping through the eaves of our roof. So our cut plane is actually a little bit too high. So what I'm going to do with my view range is I'm going to drop the cut plane down by a couple of feet just so I'm not cutting through the roof. I want to see the roof in projection. I'm actually just slightly cutting through the eaves. There. So by setting my cut plane to -2 feet, now I'm seeing the whole roof in projection. Now this isn't in the notes. It's just something that I point out to people. Okay, so now we control click those 2 rafters that we've just placed. So you've got those 2 objects selected, and we are at step 5. So we're going to use the copy tool with multiple enabled. And then now you can actually click anywhere as your starting point. And then drag straight up. You can even hit constrain to make sure that you stay going straight up. And we need 5 copies at 6-foot increments. So here's copy 1, enter, copy 2, enter, copy 3, enter, copy 4, enter, and copy 5, enter. So five copies. 1, 2, 3, 4, 5. So in 3D, it's going to look like this. All right. So let's move on to page 9. Now this is a tricky part here. Now we are going to be in the underside of beams ceiling plan, again, not the floor plan here, but the ceiling plan. So we're looking up. I'll turn shading on here so it's a little easier to see. Actually, I'll use consistent colors. So you can see the decking above, that's gray. You can see the rafters themselves there in kind of that woodsy color. So what we're going to draw here is the valley beam that goes right down from the top here down to the bottom. So what we're going to do now is use the set work plane command so that we can draw this valley rafter right on the underside of the roof. So use the set work plane command and then choose pick a plane. And I'm going to start by drawing my rafter on the right hand plane. So you can see how it turns blue when I put my cursor over it. Click. So again, set work plane, pick a plane. I'm going to pick the one on the right hand side here, and now I'm going to use the beam tool again, 2x10 full sawn. Okay, so now I'm going to start from the peak, and you'll see I get an endpoint snap there. And I'm going to go right down to the eaves, and I'll get an endpoint snap there as well. Now, after I'm done, you can see here the beam seems to be not vertical, and it isn't, in fact. The top of the beam, because we do it on a 45-degree angle, it's flush to the underside of the wood of the roof. So it's not vertical. So after we've placed it, I got to click it. And the orientation here, we don't want it normal. Normal means that the top of the beam is flat against the underside of the roof. Instead, we want it horizontal. This will make sure that the beam is straight up and down in the model. Okay, so now we're going to do another one of these things on the other side. Beam tool. Now this other geometry is going to get in the way, so kind of watch what you're doing. So I'm going to snap to the, oh, I got to use my set work plane first, don't I? Architecture set. Now you can see we're set to the right work plane. So now I'm going to choose the work plane on the left here. So keep an eye on what Revit is highlighting, which face. I want this face right here, right? This whole roof. So that's the plane I want. So now I'm drawing on that plane. Structure, and then beam. And now, just because it's kind of hard, you know, keep an eye on where you're snapping. And make sure that you're snapping to the proper endpoint. So there again, Revit is making it go flush. The top of the beam is flush to the underside of our roof. So select it after you've drawn it and switch its orientation to horizontal. Now we're going to go look at it in 3D. So there's the two rafters, and they are vertical, right? They are vertical now, the way that we'd want. But this is a little bit ugly here, isn't it? So you can use the trim command and trim these two objects. Now make sure you're back down a little bit. Don't want to be right up at the top. Be about halfway down when you use the trim tool on these two valley rafters. So Revit will kind of get them closer, but this is still, yeah, Revit isn't at the place yet where it'll totally miter these two together. I am looking forward to when Revit can do that. Now that this has been done, this valley rafter is in place. Now look at these other rafters. This rafter here, our regular rafter, our common rafter, is going to stop at the valley. So what we're going to do now is use the extend command to pull these common rafters back to stop against our valley rafter. So here, watch on the screen carefully as I use the extend command to facilitate this. So on the modify tab, I'm using this one right here, the trim extend multiple. And what you need to do now is very carefully make sure that you pick the face of the valley rafter closest to you. So here you can see how it's turning blue. There. Now I'm going to pick this common rafter. I want to pick the upper end of it, not the lower, the upper. Then the upper end of this one. Right? So those are both done. Now, of course, now that I've trimmed them, they don't need to be notched. So I will turn off the notch for these two rafters. There we go. Now, I need to repeat this process on the other side. So trim extend multiple, zoom in carefully, pick that face, make sure you're picking the face of the valley rafter that's closest to you. And then we're going to pick our common rafters and pull those common rafters back so that they terminate against the valley rafter. And I'm unchecking the box on those two common rafters because they are not going to be notched. All right, so a couple more things to do here. Wrap this up. So we've got all the rafters and a valley rafter drawn up for this side. So let's just mirror it to the other side. So in the underside of beams ceiling plan, underside of beams, not the floor plan for underside of beams, ceiling plan for underside of beams, I'm going to control click all of my rafters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 objects. And down at the filter icon, make sure it says 14. Alrighty, so now we're going to mirror these things over to the other side. Now you could use mirror by picked axis or mirror by drawn axis. I'm going to use mirror by drawn axis because I really want to see a midpoint snap here. Or an endpoint snap, that's fine too. And I'm mirroring it vertically. So now all that geometry is on the other side, and when we look at it in 3D, now we've got all that geometry on the other side. Now, what about these other two sides here? Well, a really quick way that we can finish off the rest of the mirroring is to do this. Now, I'm going to hold down my Shift key so I can deselect these two valley rafters, like so. So I've got all the common rafters on one side selected. Now in 3D, I'm going to hold down the Control key and I'm going to pick the common rafters from the other side as well. So I'm getting all the common rafters that we've made so far. So this should be 12 objects, I think. Well, 12 on each side for a total of 24. So now that we've got all of these common rafters selected, I'm going to go back into my ceiling plan here. And I'm going to mirror them by picked or by drawn axis again. And I'm going to zoom in here. And I'm going to make sure that I'm right on the corner here. And I'm going to use a 45-degree angle so that they all get copied around to the other side. And you should end up with this. So you've got all the rafters on all sides. Okay, couple of beams left to copy. In the south elevation here, I'm going to grab this beam that's in at the edge. That one right there. I'm going to copy it up to the peak so that the peak's got some support. So I'm going to use the copy command here, and I'm going to copy it from here and copy it up to the peak like that. And so that's the south elevation done. And then I need to do it on the east elevation as well. So there's the copy tool, and I'm copying from the midpoint of the top of the beam right up to the underside of our common rafters where they come up to the middle. So when you come back and look at it in 3D, you should be able to see all this lumber going right through, just like you see here. Okay, so this is the exercise that you're going to hand in for tonight so that you demonstrate that you got through tonight's class successfully. Now, with regards to the quiz, let's talk about that now. So here under activities, go to quizzes, and in about 5 minutes, I'll have the quiz ready here, the open book quiz. So you folks will be able to see that, and I'll have it so it's open from now until the beginning of next class next week, and you'll have 2 chances to take the quiz, and you'll have 2 hours at any point to complete each attempt. So if you start an attempt, get it done within 2 hours, and then if you want, you can take a second attempt, and I will accept whichever one is the higher mark. All right, folks, I'm going to end the